In the next evolution of the maze game, we're going to make a few updates and changes to it. One is we are going to use a custom font instead of just the generic font, the default font that the computer was using. So with this, I will be using a font called 8-Bit Madness, and we will learn how to implement that. When the game starts, you'll also notice there are going to be 2 enemies, not 1, but you can see how the text again has changed to this new typeface. So we'll learn about that. Now as I move through, if I have an enemy attack me, it now goes to the combat screen. Last we left combat, it just went to a yellow screen. Now we're going to resolve that. We're also going to learn about how to create the different artwork so I can get the larger versions of these without them looking junky pixelated. And then I have my 3 attack options. The game we're working with is going to be essentially rock, paper, scissors. And that gives us some really easy algorithms of how do we resolve combat. The player will make a choice, punch, kick, wink. The enemy will make a choice. Those choices will be based on what that particular enemy is. Depending on which enemy is chosen, it will have a different set of actions that it goes with. So if I choose punch, we can see punch, crush as melt. That means I was successful in my combat. And now if I click on this, it's dismissed, and now that's gone away. I scored 100 points just for doing that. Now I can go grab these pickups. You can see I'm getting more points. The ghost chased me down. Now we can see the ghost is attacking me. This time I will try and wink at the ghost, but my wink is blocked by possess. That means nothing happened. It was a tie in our rock, paper, scissors game. Now I can see that there's no change in my score. If I lose 100 points from my score. Now I'll go through and win the game. So these are now some of the updates and changes that we'll be making. So we have multiple enemies, so we'll modify it from just using enemy 0 to having a whole loop of enemies and put a couple on screen because it becomes necessary to be able to track how many enemies are attacking. So after I encounter one, I need to make that one go away and then have other ones on screen that I can interact with and then resolve out how it's going to work out. Now, if you don't want to just take away score when you lose the rock, paper, scissors, but instead want to have something else happen like lives, and if you tie with the monster, you can just keep playing rock, paper, scissors until someone wins or loses. You could certainly build that in as well. Right now, we're just going to leave it if you tie, the monster goes away and there's no harm, no foul. But if you win, you get 100 points. If you lose 100 points, which means you could finish the game with a negative score unless you put enough pickups inside the game to change how that's going to be. So the first order of business is we're going to talk about fonts and how to deal with fonts inside of processing. Adding custom fonts to processing projects is a fairly straightforward endeavor. First, we need to download the font. So I've downloaded the font 8-Bit Madness from DaFont. Here's the TTF or TrueType font file. I put it inside a data folder. Putting it in the data folder allows me to keep it locally with my project, so it does not require me to have it installed on the end user's computer so that all users of this program can then see this font, which works out pretty good. Now, once I have that font inside my project, I can create a variable to hold reference to this font. Use the create font command, and I can see up here, this is the reference file that this comes from outside or from the processing reference. So you can go read that if you want, get more information. But I use create font. I specify the font that I'm working with. I don't have to say the path of data because if I put something in the data folder, processing automatically looks there first. I can say the base size in which I'm going to create this font. We have to specify a size. It's not that critical which size we do. Some fonts we may want to specify a much larger size font when we create it, but then when we deploy it, we use text font to say this is the font I want to then be showing my text with on screen, and then I specify what size I want it to be, 24-point text or 64-point text. So if we run this, we will see then the text comes up at 20, change that up to 64. I originally had it at 32, but the text was just too small, so that's why I put it up to 64. So now we can see the difference between those as they show up on screen. So that's really all there is to using a custom font. We need the font to exist in our data folder. Then we create a font variable to hold a reference to it. We use create font, specifying the font we're creating. Then when we wish to use that font in the project, we say text font and which font we're going to use. And then it's the same as what we've done before, where we just use a text size to designate the text size that we are working with on screen. To generate the large artwork for the combat, since I'm setting it up with this kind of classic Game Boy Pokemon style combat screen where we have one character facing forward, one character where we see their back, I wanted to set it up so that I just had larger versions of the artwork, because if I use my small sheet and then scale this one up, I run into the problem that the pixels look blurry and not clean. So I need to scale these up to 10 times their original size. And what I found the easiest program to do that and to maintain my clean pixel art was inside of Pascal. So if I import into Pascal and go find the file that I'm working with, go grab my character. So we've used this before to make our sprite sheet. So I'm going to set it up that I will bring it in, and I set my size to saying this is a sprite sheet. The frame size is 32 by 32, which is what we know. So the frame that we want is for the sprite character. I want to grab this bottom row middle frame. That's when it's standing still and we see its back. For the monsters or enemies, I want to grab the top row middle frame where it's facing forward. So that's really, the facing forward is when the sprite is walking down, the facing back is when the sprite is walking up. So those are the frames that I want to grab, and then I will scale them up. So the first thing I will do is I will bring this in, and now as we look at this, what I need to do is start deleting frames. Now we know that looking at the sprite sheet, I am going to be deleting the whole first row, the whole second row, the whole third row, and then I will be deleting individual frames as we work our way across there. So I can, to work my way through this, I am going to go across. So now I've deleted the first row, second and third row, and now I keep the stationary version. And now I will delete the stationary version. And as I do this, this now sets it up so now I have the ones I want there. Now on the slime facing forward, I want its middle frame. And then on the bat, I want the middle frame. And on the ghost, I will then choose the middle frame. And spider, I will choose the middle frame. Now, we'll just go through and delete all of the other frames because we don't need the rest of the monster frames. And I got a little bit worried there at the very end. So we have spider, ghost, bat, slime, bones, girl, boy, and skin. So now we have the 8 frames that we want to work with. The next thing I want to do is to export these. To export these, I'm going to do it as a single image. So I'm doing a sprite sheet, and I want to do 4 columns and 2 rows. 4 columns and 2 rows. So I will then download this. But before I do that, I'm going to boost the size up because I want this to become bigger. And the size I want it to work with is 320, which is approximately half the size of the screen, so I can put both of them on screen. That gives me a decent appearance. So now I can hit download and save this file. So I'll just call this combat PNG, and it saves out the file. So Pascal is just a really great tool for accomplishing this. So now I can see I have matching file to work with. So now I have the artwork that I need to work with. And one of the reasons that I'm setting it up with these 4 in the same order is so that when I choose a character, then it's going to help me choose which one to display here. So if I change what the character sprite is, it will update that character. And depending on which enemy is being engaged, it will show the correct artwork that lines up with that as well. And we'll figure out how to do all of that shortly. I've added the data folder with the font to my project so that I can start using the new font. So we're going to work with that. We're also going to add in the combat artwork. So I'm going to make a value to store reference to it. I'll call it combat art. Now I'm also going to, as I work my way down here, this is where we're going to want to put in the font. So I will just call it 8-bit font. The next thing I need to do is to populate those. So combat art is going to be load image, combat PNG. And as I scroll down, now I'm going to just populate that now. So 8-bit font is going to be create font, and it is 8-bit madness.ttf, and I can store it at a size of 64. One other thing I want to do is add in a second enemy, so we have that. We'll do a second enemy later. First, we'll get one enemy working with our basic combat. Now, doing nothing else, I've done a couple changes. It's always a good idea to run our project, and when I do that, we can see that nothing has changed yet, because even though I created the font, I'm not using it. So this is where I can use that font, and I can say text font 8-bit font. Now once I've done that and run it, we'll see that it changed it to give me information. Now if I want to change that size, so that size is different, we could start out and say by default we want all text, not text font, text size to all be 24 by or 12. You can see 12 is probably a little bit too small. 24 is pretty close to the default size that we had before. We can see that my other text is now lining up inside that same option. Now the ghost chases after, we go to the combat screen. So we've proven that the font works. We are now able to add it to our project. So by having these lines here at the beginning, which this text font, if this is the only font we're going to use in our whole project, we could probably just put the statement right there. Having text size 24, if that's going to always be our default text size, by leaving this here, that will reset every time the dry loop resets, and then anytime I want the text to be a different size, I can just specify that before I show it on screen. So during the combat section, I will probably want my text to show up in a different size when I'm getting information about how that combat is being resolved. You need to keep in mind now as we're going to go and populate combat, and I'm going to tone combat down a little bit because the bright yellow is a little fatiguing to look at on the eyes. Ideally, you would have artwork that you would put in the background instead of the bright yellow, because that's just a little strong. Or, yeah, so if you had a picture or something, a little kind of combat landscape that you wanted to show in the background, that would be preferred. What we want to figure out as we work with that is looking here. I'll notice that the characters, as they're put on screen, we have 0, 3, 6, and 9 that correspond to each of these characters. That's because 0 gives us the character, the first character grouping. The second character grouping is 0, 1, 2, 3, then 4, 5, 6, 7, 8, 9. So we have this multiples of 3 that we're working with, And we're going to be able to use that information so we don't have to store yet one more variable. We know that these are all groupings of 3, but we really want, instead of 0, 3, 6, 9, we want 0, 1, 2, 3. Well, the simple math there is we just take those values, 0, 3, 6, 9, divide them by 3, and then that will give me 1, 2, and 3. So 0, 1, 2, 3 will correspond to the values that we're working with here. And we'll see that come into play when I want to then show those images on screen. So once again, we'll use our copy pixels command, and then combat art, and then we will display the sprite at its offset x. So offset x said which grouping that we're working with, because we're offsetting our x value, 0, 3, 6, 9. So we're going to be dividing that by 3, but we're also going to multiply it by 10 because the amount we're offsetting, we are now going up by 320 pixels. And if I look in the sprite, we can see that the offset was that number I'm offsetting, 0, 3, 6, 9, times 32. But because these are 32 pixels wide, the big ones we're working with now are 320 pixels wide. So that's why I need to multiply it by 10, but then we will divide it by 3 to get the number that we are looking for. Now, that's our offset on the x. Our offset on the y is going to be 0 for displaying the character here, the top row. And then we will grab a section of pixels, 320 by 320 pixels. Now when I put it on screen, I'll move it over 25 in from the edge. And I will grab, and I will kind of center it vertically on screen, knowing that my screen is 640 pixels tall. This is 320 pixels, so that's going to mostly put it on screen. And then I'll show my artwork at 320 and 320. Now, to speed up what I'm doing, I'm going to just modify the game. So I just start out in combat. So then I don't have to run into it. I'll just start out in my combat mode. And now when I run it, maybe we'll see it comes up and it now drew my character here. So it started at the middle of the screen, it moved it over 25 pixels, and it drew my player character. Now if I were to change which sprite I'm working with, instead of using the boy, if I were to use bone and run this again, we will see now it changes the one we're working with. Again, it's taking advantage of that offset. The next thing that I want to do under combat is display the opponent. And this time it's going to be almost all the same, but I need to shift down, offset my Y 320 pixels. And when I put it on screen, instead of putting it at 25, I'll put it over at 300, and then I will start my Y at 0. So when I do this, I will now see there's the spider, there's the player. So now our two critters have been successfully rendered to our combat screen. Next, we need to add a representative clickable button to work with. So I've just put 3 ellipses on screen so that we can see those again. Now if we run this, we see there are the 3 buttons. After that, I need to put some text on screen. Now for putting the text on screen, what I can hard code it in, but instead of hard coding the text in, to store this information, what I'm going to do is I'm going to add it into my sprite class. So, and I keep meaning to get rid of it. We're not using ground anymore. So I'll just put it there. We don't need that. Since we're not using ground, there's no reason to keep that as part of our item. So I'm going to make an array of strings, and I'll call it actions. This is what we'll be adding an array of actions for each one of the enemies as well, so that they all have different things they get to do, because the spider, ghost, slime, and bat should all have different attacks that they are working with. But first we'll deal with the character's actions as part of this. So I've now created that placeholder for that, and I will now populate this. So actions is going to be new string square bracket, and 3. So there are 3 actions, rock, paper, scissors, that we get to work with. So action 0, in the beginning right now, we will do it as rock, paper, scissors because it's easier to keep track of. Is our code working or not? We will then change it to be something else later. But the reality is we don't really need that because we just care about that the actions are 0, 1, and 2. When our actions are 0, 1, and 2, the enemy has actions of 0, 1, and 2, and then we determine if 0 is rock, 1 is paper, and 2 is scissors. We're able to come up with a pretty neat little way of determining what is the victor in each of our encounters or combats. So this is 1, this will be 2. So rock, paper, scissors. So now we have our 3 actions that we're able to work with. I go back to combat. I'm going to put the text on, fill it with white. We'll align the text to center. So the first one I'll grab, I'll just put the text for the first action that's there. So it should display rock. When I look at it, we can see it does. It puts rock into that. So now that means I just need to choose the next 2. And we'll see it puts them all on top of each other because I did neglect to update their X position. So now as I run this, we can see that rock, paper, scissors are showing up and are populating my different buttons. I would encourage you to think about making your buttons actually make artwork that you display instead of just drawing an ellipse so that it fits with the same. I mean, if you're going to stick with the 8-bit style, which I think is kind of fun in this particular project, then make it look like 8-bit graphics that are populating the screen at that point. The next thing that we need to do is to find out which button is being pressed so that we can display that on screen, or to work with it to start our combat operation. So the way that we can do that is if mouse pressed, and if we press the mouse, then what we want to determine is if the distance of our mouse X, mouse Y, and the center of the button, which the first button is 300, and then height minus 100. The buttons right now are all 100 pixels wide, 100 pixels tall, so half of that. So if these distances, so if the distance between those 2 points is less than 50, that would indicate that our mouse is indeed over that button. Return twice, close curly, up arrow once, and now what I'm going to do is print out this first button is rock. So we're going to, well, lowercase l. Now if we do this, put my mouse over it, we'll see I barely touch the button and it prints it out a whole bunch of times. So what we really want to have happen is we want it to happen just one time, and we will take care of that in just one moment. But I'm going to, I can't be in 3 places at once. So that means I will never be able to have all 3 of these, so I don't really need to use else if. I can just use 3 separate else's. So rock, paper, scissors. If we run this, watch, there's rock, there's paper. I barely click the button and I showed up 5 times. Click rock, 4 times paper, 3, rock 3. I hold down more. So it's all based on pressing the button. So that's going on for a little bit too long. So instead what I want to have happen is I want to set it up so that I know whether I'm actively engaged in combat or not. And to do that, what I'm going to do is have another variable. Now eventually I will want to move this variable to my main section in the program. So inside the maze day file. But remember, this file, this combat file separated, is just an extension of this whole file. So it's just like if we put state play into its own separate file, we could put state start, each of these into their own file to keep it more organized if we wanted. So I'll set this equal to false, because one thing is these variables, I don't have access to setting them inside of setup if I'm declaring them after setup has happened inside my program. So now I've set that up. So fighting is now false. So fighting equals true. Copy that. Paste that in a couple times. And now what we can do is add a statement. So if we're not fighting, then I want to click one of these, and then if I press it, then. So this means I will only be able to choose one option. But we can see it once. Now I press any of the others, nothing, because I have no way to set fighting back to false. Now we can see that this is repetitive that's happening here. This is probably not going to be our best way of working with this. So what we probably need to do is we need to pull out and separate what is going to happen during actual combat and show that to the player on screen. And this is where we're going to start resolving the rock, paper, scissors combat algorithm. To resolve our combat algorithm, what we're going to do is create a fight function. Now this fight function, we're going to pass into it a value. So with this, we'll pass in a value, and that will be the choice of the player. Eventually we're going to need to pass into it which enemy we are currently fighting. So we will need to pass that information into it as well. So what will happen is when we go to combat, when we go into our state of combat, then we're going to need to know what enemy triggered that, and then we'll pass that enemy's value into this fight. Now, to figure out rock, paper, scissors as we work with it. So 0 is rock, 1 is paper, 2 is scissors. If we go back to our sprite, we can see that that's what's happening. 0 is rock, 1 is paper, 2 is scissors. Now, what I'm going to do is we are going to set that up inside the enemy as well. So the enemy has that so we can work with it. So I'm just going to copy that value, go into the enemy, paste it in, and then go back into the sprite. And again, currently we're going to set it up so that the enemy just has rock, paper, scissors. Eventually we're going to modify the enemy, so depending on which enemy is chosen, it's going to then have a different option for it. Rock, paper, scissors added to the enemy's actions. The sprite has rock, paper, scissors. Now we're going to look at combat. So 0 is rock, 1 is paper, 2 is scissors. So winning combos would be 1 over 0. So rock beats, paper beats rock, scissors beats paper, and rock beats scissors. So those are the 3 winning combos. The 3 losing combos are going to be when the player chooses rock and the opponent chooses paper, because paper covers rock, or when we choose paper and the opponent chooses scissors, scissors cuts paper, or if we choose scissors and the opponent chooses rock because the rock crushes the scissors. Tie combos, of course, are where the numbers match. Now, the interesting thing about this that we can see is if we have that, we randomly choose one of the enemy's choices. If we choose a choice 0, 1, or 2, that's going to give us some version of the combo. So if we always put the player first, then what we're going to be able to determine is that if I look at this and if I take the player's number minus the opponent's number, 1 minus 0 gives me a result of 1. 2 minus 1 gives me a result of 1. And 0 minus 2 gives me a result of minus 2. So if the result of my match is 1 or negative 2, I have 1. But now if 1 is in WON, not the number 1. But if I choose rock, opponent chooses paper, I've lost. But 0 minus 1 is negative 1. 1 minus 2 is going to be negative 1. And 2 minus 0 is 2. So what we can see is these three give me different results than these three using simple math. So I either have a result of 1 or negative 2. That means I have 1. But if the numbers chosen are the same, then we tied. Any other result means I failed. So I don't have to use a complex if-else-if statement. So I could use an if-else-if statement to go through all 9 of these options. Or I can just have a simple, did I have a tie? Meaning the choices were the same. Or did my result work out to be 1 or negative 2? I won. The final result means I lost. So we're able to do it fairly straightforward. So first I'm going to create a value for the enemy choice. And that is going to then be a random number on this. And it'll be, so I will round down and I'll choose a random number between 0 and up to, but not including 3. So that now gives me the enemy's choice that I get to play with. So now if player choice is equal to enemy choice, at that point we have a tie. Else if player choice minus enemy choice is equal to 1, or player choice minus enemy choice is equal to negative 2. So if either of those two things happen, we know the player wins. Else player loses. So this is the core of the combat algorithm for rock, paper, scissors. So we either tied. If we didn't tie, we find out have we won. If we haven't won, the only other possible option is that we lost. So now what we can do is temporarily so I'm just going to print it out. My player and with this we will check out what the player's choice, we'll print out the player's choice. And then after that, we are going to print out the enemy's choice. But actually, what I want to do is I'll grab the enemy's action and print that out. So that's now going to print out what the player choice was and what the enemy choice was. Now this player choice, we need to pass that in when we call the fight method. And then once we do that, then what we can do is set back to true, so we can, or false, so that we can then resume fighting once more. So instead of printing that out, what we can do is call fight, and now the choice that we've made is 0, 1, or 2. And I realize I had spelled enemy wrong here with an extra E. We don't need that. But also here I said the enemy's actions, but we don't know which enemy we're working with because we didn't pass it in when we called our combat. So for the time being, I'm just, well, no, we'll just set that up and we'll add it in so it's done, because the enemy has action, so we can work with it. So currently inside our game, what we want to do is when we call combat, we need to then specify which enemy we're working with. To determine which enemy we're working with, what we'll eventually do is when we collide with that enemy, then we will set that as the current enemy. But right now, what I'm going to do is I'm just going to pass in the one enemy that we have. So we'll pass that enemy in. So now when I go into combat here, we'll pass in that enemy value. And now when we call fighting, we will also want to pass in the enemy that we're working with here. And that now means each time we call fight, we'll pass in the player's choice and the current enemy that we are working with here. Because eventually we'll store it in a value called current enemy. We're just not there yet. But we can set that up very soon, so we don't forget. I'll do it right now. So I'm in the main program file. So it's important to, when we're adding things, to pay attention to which file we're in. So I'm in the main program file. And with this, I get to specify what kind of enemy, or what enemy we're working with. So it will be our current enemy. So we have that. We'll populate current enemy during a collision, but for right now, when we set that game state, we're just going to pass in the fixed one. But eventually, we will change this to current enemy, and current enemy will be set when there is a collision here, which I guess there's no reason not to, as long as I spell enemy correctly. So we'll pass in the current enemy right there. And what I will want to do is just, this is temporary. We'll put a note, remove later. Current enemy is going to be equal to enemies. Because when we have more than one enemy, that will matter. Right now, we only have the one. So now when we have that collision here, because all of these options with enemies, we'll be wrapping this into a for statement, or a for loop when we have more than one enemy, so the 0 will become an I. but the current enemy is there. So if I changed it back, so we started with start and then ran into it and went to combat, we would pass in the correct enemy. So now going back to our combat file. So we pass in the enemy when we are working with this, so now we know what the current enemy is. When we call the fight function, we will do that. Now it doesn't make sense to have fighting true 3 times when it's the same, so we'll get rid of these, and inside of the fight method, that's where we will set fighting true. After we fight, then we can set it to false. What we're going to find is this goes by really fast. We will need to modify it a little bit, where we will have to allow the player to have to click on something to dismiss the results of the battle, so it doesn't keep fighting as we go. Now if I run it, we can see on that click rock, paper, rock, 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 rock. If I go here, paper, scissors, so we can see it's giving me what happened with it, but it's not telling me necessarily who won. So that's where we're going to want to construct something a little bit different in our messaging. But what we can see is we get scissors, rock, scissors, paper, scissors, scissors. So that was when the player chose scissors, those 3 that went off, actually 4, rock, rock, paper, scissors, gave us the result. So we never know what it's going to be. It can give the same thing multiple times. So sometimes you'll do it, you'll think it's broken, but it's the randomness. When we only have an option of random of 3 separate numbers, we don't get a great amount of variety happening at that point. So it's mostly working, but this message, as we're working with it, we will want to modify it so that we have a tie message, a win message, and a lose message that we're working with, instead of just simply putting this message out. So to do that, we're going to store the information of what we want to say in a string variable. So the string variable will be our combat result, and we'll start out with it as an empty string. So now what I'm going to do is say combat result is equal to, and this is where we get to populate it. So it's going to be the player's choice. So I'm going to just copy that, paste it in, player's choice, and I'll just say blocked by, and then with this we will grab the enemy's choice. So now we have our combat result, so I'll copy that, paste, paste, but now, so the player's choice, we'll say when I win, I destroy whatever they did, and when I lose is wrecked by. So now, instead of printing out the previous message, so now we have these 3 messages. So when it says blocked, we won, destroys, or blocked, tied, destroys, win, wrecked, loses. So now if I run it, you can see we got wrecked, blocked, blocked, wrecked, wrecked, and then blocked, destroys, wrecked, 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 wrecked. So apparently I'm doing really badly. Hey, I finally won something. So we got a couple wins, but a lot of losses going on there. So that was a pretty brutal set of combats. Going back to the top of our combat function, we'll see now we've taken care of when we're pressing the mouse, but what I want to do is I want to set it up so that when I am fighting, meaning we now have a fight result to display, what I want to have happen is I want to be able to then display that result on screen. So I'll say if fighting, and inside of that I'm going to drop a translucent overlay of black over the whole screen, so that will mostly cover things. So that now puts the box on top, and then I'm going to draw a box on screen. And I'm just going to do a dark red color. If I want, I could make it translucent, but what I would even encourage you to do is to have a picture or a graphic that you use instead, so you can have a nice decorative border as part of it. So I'm going to make this box 400 pixels wide, and it is going to be 200 pixels tall, which is why I'm centering it on screen using the middle of the screen width divided by 2 minus 200. So now I can make it 400 wide, and then I use the height divided by 2 minus 100, so that means I get to double that. So this now draws a box dead center of the screen, and now what I'm going to do is choose a font size of 64. So it now makes it, or sorry, let's try that again. Text size 64. Text align. Center, center. So this will vertically and horizontally center it at the point we're going to draw it on screen. And with that, then I will draw my text of my combat result. And I will center it on screen. So now I have put my text on screen. Now what we can do is make it so currently I'll turn off resetting fighting. If I run this, if I go, we can see that we have some issues going on. Our text, I forgot to give it a color, and the text is going too wide, so we do need to modify the text by putting some line breaks into it. The way that we're able to put some line breaks into it is we use the backslash and the letter N. That gives me a line break. So I'm going to, now this is the slash underneath the delete key, not the slash next to the shift key. So it's important to keep that in mind, but this backslash N says put in a carriage return. So it's a non-breaking, so it doesn't create a new paragraph of text, it just breaks the text and puts it onto the next line. So that now gives me the text that I am putting onto my lines. And going back into my text, I want to give it a color as I put it on screen as well. So now when I press the button, we can see my text shows up, it's on screen. What I want to do is when I click on screen, I can make it so I can click on the box, or I can click anywhere on screen. Now if I click anywhere on screen, I run into a problem in that it registers very quickly that I press the button, it shows the result, but then as we saw where it's giving all the double results at times, then that makes it problematic as far as having it stay on screen. So what we want to do as we're checking, so if I press the mouse and we're fighting, we want to do this. But if I'm not fighting, else, if I press the mouse and fighting is going on, this is where now what we need to do is find out, is the mouse inside the rectangle? And the way that we're able to do that is we have to check is the mouse greater than the left edge, but less than the right edge, greater than the top, less than the bottom. If those 4 values all work out, then we know that we are inside the box when we pressed the mouse. So there is no magic. Hey, I drew a rectangle. I want to know, did I click on that rectangle option? We actually have to query things a little bit better. So my left edge, so if my mouse X is greater than the width divided by 2 minus 200. So again, remembering that when I drew this box, these are the values that we're going to be checking against right here. So if my mouse is greater than that and the mouse X is less than width divided by 2 plus 200, and so we're just going to put a couple returns here to make it a little bit easier to keep track of. So I'll go here, and if my mouse Y is greater than the height divided by 2 minus 100, and the mouse Y is less than height divided by 2 plus 100, that would indicate that we are indeed inside the box. So if that's the case, so we'll just kind of align this up. There we go. We'll use auto format to clean it up. So if I press the mouse and fighting is true and the mouse is inside that red box, at that point fighting is going to be equal to false. And that will allow me to keep running through the game. Now that I can do that, what I want to do is then, after I've successfully engaged in combat, exit combat and go back to the game. So now if I go here, rock is wrecked by paper. Yep, that works. And now if I go here, paper is blocked by paper. Good. Scissors is blocked by scissors. Good. Scissors destroys paper. Paper is wrecked by scissors. Paper is blocked by paper. Paper is wrecked by scissors. Paper blocked by paper. Wow, we keep getting the power of random. This is why it's, there we go. So we can see that it is indeed working. It's giving us the results. So now what we would do is once I click that, I would exit this and go to the game. We're also going to be looking at, when I win, what needs to happen to my score. When I lose, what needs to happen to my score. So we will put that in now because we're going to go back into the game and add that in as well. So my score will go up by 100 if I win combat. But my score is going to go down by 100 if I lose. So we could finish the game with a very negative value. So in addition to setting fighting false, we could now send it back to the game because we're going to now use the collision with the enemy to see that happen. So when this happens, I want to set my game state back equal to play. So now we go back to play. What we also should do is we need to tell the enemy to get rid of itself. So to tell the enemy to get rid of itself, what we're going to do is we'll tell the enemy to hide. We could also tell the enemy to die or whatever else, but I'm just going to go with hide for now because that's easy. Now it's going to tell me, it's in red right now because it says enemy, oh, sorry, it's E. But it says E does not have a function called hide yet, so we need to add that to the enemy class. Enemy class, a couple of things I want to do. I want to set up a Boolean here. This Boolean, we'll call it dead. And in the beginning, we won't be dead. So we're not dead. Now, I only want to have the enemy chase after the player if they're alive. So we're going to find out why that's important in just a moment. So what I'm going to do is to create this hide function. So it will be void hide. And inside this function, I will set my x equal to 0. Y will be set equal to 0. And dead is now going to be equal to true. We'll figure out why we need to use dead in just a moment. Now, let's go back and let's see the kind of enemy we're working with in this particular one. It's the ghost. The ghost goes through walls. That's going to be useful when we get to watch this happen. And my game state, I'm going to start out my game state with start. Now, when we run this, we'll go here, press a key to begin. So now the ghost is here. All right, let's see. Combat, rocks wrecked by paper. Okay, I lost. Click, I'm out of here. There's the ghost. But now, if I, oh, look, see, the ghost is now coming back from the grave. Well, he was already dead. That's, hey, I won that time. Oh, crap, he's still chasing me. That's bad. And, oh, he's still chasing me. See, again, that's really bad. So this is why inside the enemy, what we want to do in the enemy is we only want to be chasing. So if the distance is less than 200 and if we're not dead. Because dead starts out as false and we want to, that's supposed to be inside that parenthesis, my bad. Go here. So if we're not dead, and the distance between the sprite and the enemy is less than 200, then we start chasing. So now the enemy, once the enemy is dead, okay, there we go. Oh, we got a little problem here. We got the spider showing, and I wanted to ghost, okay. Good. That's weird. But see, you can see now the enemy's not chasing. So it seems that inside here I forgot to specify that we want to see the enemy. So it was because I was using the bone one here, then it used the spider because they both had the same offset x, thus it was grabbing that value. But because we are now passing in the correct enemy value, then we use that enemy's value. So now if I start out, I can see that I have the slime occurring. So when the slime chases after my player, there's the slime. I got wrecked, slime is over there, and slime will not follow me. Now we can see my score went to -80 because I did get squashed by the slime. All right, so score went up, but again, it's a negative score because I don't have enough pickup objects versus the enemy that I'm running into. What I want to do next is to just add in a second enemy, so that we have 2 to work with on here. So instead of 1, that will be 2. And enemy 1, we will make enemy 1 then the ghost. And the ghost can go through walls. The slime can't. So we will have the ghost start out. We'll move it over a couple areas over there. We can get rid of this current enemy because that won't matter because now we are using collision. So again, remove later. We've now removed it because now the time is indeed later. So with that, I run into the enemy. But this now is only using a single enemy, so we now need to create a for loop. So for, oh, I've got a few fat fingers going on there. Int I is equal to 0. I is less than enemies.length. ni++. Now I will just take all of this here, cut that, put it into the for loop, and then change all these zeros to the letter I. And now when we do that, all our enemies are going to display, and it will should know which one we engaged with in combat. So we'll fight the ghost first. Ghost, that works. Scissors. Hey, I won. Ghost is up there. Now let's go. Now let's fight the slime. Slime works. Hey, look. That's perfect. All right, so we're in really good shape. The final thing that we want to do here is we want to set it up so that based on the type of enemy that we are fighting, the actions aren't rock, paper, scissors, but instead are going to be a little bit more interesting and appropriate to each of the creatures. So we know which character we're passing in. The characters are slime, bat, ghost, and spider, so we have a character reference that we can work with on that. So what I want to do is I'm going to replace this actions here with a switch statement, and in that switch statement I am going to be going between different characters. So I'll switch between the characters. So if the character is slime, I want to use acid, dissolve, suffocate, or melt. If it's a bat, it's bite, wing, buffet, or screech. Ghost would be scare, haunt, and possess. The spider will be venom, bite, web wrap, and leg crush. So I now have my different actions to correspond to each of my enemies. This also means on my sprite I want to update these. So I will use punch, kick, and wink. Doing that, now when we engage in combat, we have a little issue somewhere. Oh, I still needed actions here not to be commented out, so I'll just move this down. Got a little ahead of myself. So these old ones, rock, paper, scissors, I'll leave that there for now, but we will clean those out in a short while. So now if I go and chase after the ghost, if I punch the ghost, punch is blocked by scare. Okay, that works. Now, oh, slime's after me. Let's kick at the slime. Oh, I was wrecked by melt. I think my leg just melted off when I did that. It's also possible as you do this that you don't have to have it always the same in the middle, but you could have an array of successful words, losing words, and tying words. So if you came up with a vocabulary of that, you could randomly grab from that. So the messages become even more interesting or engaging as part of what you're doing. But as you can see, we now have multiple enemies. We are able to make them go away. They can have individual methods that are associated with them. The sprite has more interesting things. Combat shows up on screen, gives us some great stuff. What the game doesn't have is any type of reset on it, but it's getting really close to being fully functional.